You probably see by now the pattern that we are just randomly going through things categorized into carbon footprints and the boxing of them into less than 10 grams, 10 grams to 1 kilo, 100 grams, above 1 kilo. Now we'll go into tons and so on. It's not always as rigorous as you would like, because doing life cycle analysis and extracting carbon footprint is a very difficult job. But again, keep the relative carbon footprints in mind. So we'll jump to a fish here. Trout, even though, as the author points out, it's not very common to see trout in a canned form as opposed to tuna and sardines and anchovies and so on. 1 kilogram of trout has 5.9 kilogram CO2 equivalent when it's canned, 6.9 kilogram CO2 equivalent fresh from the store or frozen. So it depends on how the processing is done. People do life cycle analysis for tuna, for example. Most of the tuna canning happens, let's say, in Thailand, far away from the oceans where the tuna is actually caught. So the best tuna may go directly to sushi markets and so on in Japan and elsewhere. And the countries go far to get their fish. Japanese, of course, Chinese, US, Spaniards, Chinese, I mentioned maybe. They go all over the place, far away from their homeland to catch fish in international waters, and there are international bodies that try to regulate fish management, but there are a whole lot of issues on bycatches and even how to monitor the quotas and so on and so forth. So quickly, if you look at various types of fish and their carbon footprints, either in kilogram CO2 equivalent per kilo or per pound. So you have mackerel, fresh fillet, herring. So this is increasing in this order. So I won't read the numbers. You can look at them. Unprocessed shellfish, unprocessed general fish, cod, fresh fillet. I'll show a figure from another paper in a minute, but you can see cods as fresh fillet at the factory gate, frozen fillet at the factory gate, and fresh fillet at the checkout, fresh fillet at the factory gate, frozen at the checkout, and trout and flatfish, frozen filleted fish, shrimp peeled and frozen. So some of these things are very common, and we are not talking yet about aquaculture here. Aquaculture has a whole lot of issues, wants to meet the demand for fish. For example, countries like India, where economic growth comes with expanding middle class, then meat consumption and fish consumption goes up. So the question that often comes up is whether fish is any better than meat. That's not always the case, because obviously it depends on how and where the fish is being served to you. Fresh, frozen, canned, etc. Right? So if you look at tinned versus fresh, looking at farming and catching. So farming is where you take the juveniles and then you feed them. Aquaculture is, I think, where they're growing from the beginning and so on. So there are details. Processing, packaging, transport, supermarket, adding footprint excluding refrigeration and refrigeration in the store. So obviously when you say I love my fresh fish, you may be adding a carbon footprint by doing that. Is that a bad thing? Not necessarily, because it's better for your health. So the externality of the health cost is not included when we just go for carbon footprint. So obviously one has to always worry about these things. Can a seafood product be environmentally friendly if it has a massive carbon footprint? So you look at carbon footprint in kilogram CO2 equivalent per kilogram of edible product. A lot of the fish parts get discarded, and then depends on what happens to them, may become chicken feed or back into the ocean and so on and so forth. So here are potatoes, apples, milk, chicken jumps out, herring, cod jumps out, salmon 1, 2 and 3 depending on whether it's fresh caught, farmed, and so on. So I won't go into the details. If you look at carbon footprint again in terms of kilogram CO2 equivalent per kilogram of edible product, you can look at the domestic market, international market, and global average. So obviously these things matter as well, whether you are buying local or it's traveling and adding other costs like refrigeration and transportation. Every morning 4 a.m. a big ship or a big aircraft full of fresh sushi grade tuna lands in Boulder, which is in the middle of the continent, and yet Boulder is one of the best places for sushi, far away from the ocean. Okay, leaving the lights on, 90 kilogram CO2 equivalent if it's a low energy bulb for 1 year. Obviously you don't want to leave the light on for 1 year, but it amounts to that in terms of many places where we simply leave the lights on and don't even think about it. 500 kilogram CO2 equivalent if it's a 100 watt incandescent bulb for 1 year. Obviously incandescent bulbs are mostly being outlawed in most places, so that's good news. So this image is always telling in terms of the composites of night lights across the globe by NASA satellites. One of the points made in social science context is that just because there are places where there is less light compared to places with more light doesn't mean there is a lower population density. It could be access to electricity and other things. But nonetheless, you know that when you walk around the marketplace in even the smallest town in Africa or India or anywhere, you have lots of lights on. This has become part of the culture. Obviously that's something that is adding a lot of carbon footprint, energy consumption as well, especially when the energy is coming from coal burning and not from renewables. Okay. Finally in this section, steel. 1 kilogram of steel has 0.42 kilogram CO2 equivalent if it's recycled general steel, 2.7 kilogram CO2 equivalent if it's virgin general steel, 6.15 kilogram CO2 equivalent if it is virgin stainless steel. So virgin general steel has about 3 times the carbon footprint of cement, for that matter porridge made from half milk and half water, per pound. But there is a lot of debate about whether concrete, which doesn't have a similar lifestyle as steel and has other issues with water and so on, can be replaced by stainless steel for infrastructure, bridges, buildings, and whether that's more environmentally friendly over the long time scales. But the key factor here is the country of manufacture. This can make a big difference for 3 reasons. Steel manufacture requires electricity, and the carbon intensity of this varies from country to country depending on how it is generated. The amount of energy used also depends on the inefficiency or efficiency of the steel plant, with less developed countries often having less efficient manufacturing. A final small consideration is that if the steel is made a long way from the final market, there will be an additional shipping impact, and steel is heavy, so lots of it gets transported around to the places where buildings are made or other applications like pots and pans and so on are made. Just to run through the numbers, carbon emissions in the percentage of US production, so US is used as a standard at 125% in Australia, 225, 175, 200 and 300 in China. Okay, so obviously jumps up to 3 times if it is not in the US. You can look at lots of other countries with much bigger footprints. Nigeria here, massive number. Who else is big? India is at 500, Colombia at 600, and so on and so forth. Okay, so steel, lots of issues about whether its carbon footprint compared to cement depends on how it is used, and whether cement in the long run is less durable, adding more carbon than when it's first constructed, versus steel, which has different life cycles and so on and so forth, and where it's produced as well. So sustainable lifestyle is a tricky expression. It doesn't bear much scrutiny. It's become almost a cliche, and we could get hopelessly bogged down in defining it. However, I strongly suspect that whatever definition, I would still stand by whatever your definition, I would still stand by my assertion that it leaves plenty of scope for reading. Okay, so obviously we're getting into items where steel, for example, is not something you buy on an everyday basis. It's not like egg and coffee or steak and so on. So we are comparing things that are not easily comparable in a person's life. But whenever you have to use cement versus steel, or eat a banana, you can always remember these numbers and how they add up. And what you can in fact do in terms of reading more before you make your choices. Okay, always good to remind ourselves of these sorts of details. Okay,